Hi everybody. So let's look at imaginary units. So far, discussions you may have heard if you've been watching my videos, we've been discussing that the square root of a negative value is not real. Okay, you don't want to say no solution, it's not possible. It is possible, it's just not real. So we came up with the definition for the square root of a negative 1. We're calling it I, okay, standing for an imaginary unit. Also a definition is I squared equals negative 1. And so this whole concept we're going to put into play, but whenever you see I, or the square root of a negative 1, that's I. And whenever you see I squared, it's a negative 1, okay? And this sort of thing, by the way, people say, well, when am I going to use imaginary units? Electrical engineers use this all the time. People using Euler's theorem and things like that, they use it all the time. Fractal geometry gets used a lot. So it does have its place in a lot of mathematical communities. Depending on what your major is, you may or may not deal with it in future courses and whatnot. But for right now, you have to. So here we go. Let's take a look at what happens if we got I equals I squared equals negative 1. What about I cubed? Well, think about that for a minute. I cubed, would you agree it's the same thing as I squared times I? But remember, I squared is a negative 1, right? So we're really talking about a negative 1 times I, or negative I. Now let's look at I to the 4th. Would you agree that that's I squared times I squared, or negative 1 times negative 1, which is a positive 1? Now let's look at I to the 5th. Well, would you agree that that's the same thing as like I cubed times I squared? But let's see, I cubed, we figured out that that's a negative I, and I squared is a negative 1. So that's a negative I times a negative 1, that's going to be a positive I. Interesting. I to the 6th, we could keep going, but hopefully you're going to start seeing a pattern here, right? This I just repeated itself to be I. I to the 6th, it's going to be a negative 1. I to the 7th, it's going to be a negative I. I to the 8th is 1. So they go in intervals of 4. Okay? Goes I, negative 1, negative I, 1. I, negative 1, negative I, 1. So they go in intervals of 4, which is all fine and good. But what happens if you've got I to some really big number, like in this case, I to the 2,756? Ooh, that's big. 2,756. Well, a couple things here. If you remember your divisibility rules by 4, you would remember that your last two digits, if they're divisible by 4, then the big number is divisible by 4. So really, what I'm saying is if you have a giant number like this, just look at the last two digits, divide that by 4, and look at the remainder here. So we'll do some long division here. 4 goes into 16. 4 goes into 5 one time, bring down the 1. 6, bring down that. 4 goes into 16 4 times, minus 16, so you get 0. So I got a remainder of 0, which means this is really I to the 0 power. But anything to the 0 power, providing the base itself is not 0, is 1. So I to the 2,756 is 1. Suppose I did I to the 2,757. Okay, then you would have taken 57 and divided that by 4. I'll go a little quicker this time. You're going to see a remainder here of 1. So I to the 2,757 is the same thing as I to the first power, or just I. Well, that's all fine and good. Is there an even faster way of doing this? Yeah, there is. If you had a calculator, think about it this way. When you do the division, you're going to have one of 4 options, right? You're either going to have a remainder of 1, a remainder of 2, a remainder of 3, or a remainder of 0, which is the same thing as no remainder, right? So, on a calculator, if you do the division on a calculator, you're going to get some kind of a decimal answer. That's some number 0.25. That means you've got I. If you do this on a calculator and do the division of some big number, divide it by 4, and you come out with some number 0.5, then you're looking at -1. If you take that big monster number, divide that by 4, and you get some decimal answer, you come up with some number 0.75, well then you're looking at -I. And if you take that great big number and you divide it, it's actually going to go out even. It'll divide in there evenly, so that means you're not going to have a remainder, so you'll have a decimal of 0. Then you're looking at 1. Alright, so that's how you can do this if you're using the calculator, which is kind of cool. So go ahead and try that out and see how it works for you.